Bill Nye, the man of science, has been thrilling us with the latest discoveries and all their mysteries for decades. Bill Nye has piqued our interest in the final frontier and its enigmas as he introduces us to the vastness of space that surrounds us and stretches infinitely above us. Now, Bill Nye breaks the silence on the most recent images from the James Webb Space Telescope, JWST, which offer us a glimpse into the universe more than 13 billion years ago, fundamentally altering our knowledge of the cosmos and our perspective on life itself. This telescope is making discoveries about planets, distant galaxies, and much more. It is a revolutionary scientific breakthrough and a worthy successor to the Hubble Space Telescope. What is so special about the JWST images that defy our expectations and theories, and what does Bill Nye have to say about them? The creation of the site was the result of years of work by NASA scientists and engineers and was launched on Christmas Day, 2021. The various steps of the telescope's deployment proceeded smoothly. Over the next few months, by the end of June 2022, scientists began to discover thousands of new galaxies, older and more distant than previously known. Some of these galaxies may have been formed 150 million years before Hubble's oldest discovery. In addition, the telescope is able to capture enough light from celestial objects, such as exoplanets and stars in formation, to show the atmospheric composition of planets light years away from Earth, allowing suggestions to be made about their potential to harbor life as we know it. One of the Hubble Space Telescope's most recognizable sites has long been the Pillars of Creation in the Eagle Nebula. This structure was visible to the telescope but primarily detects visible light, but the processes of creation within it were not. However, they were captured by the Webb telescope's infrared image in the form of many protostars. These appear as clusters of dust and gas, each several times larger than our solar system, appearing as tiny red dots against the background of the pillars. These are stars in the process of formation. The stars visible in the photograph are not yet consuming hydrogen, according to Bill Nye. However, as more material is attracted to the center of the star, it becomes denser and denser until it suddenly reaches such a density that hydrogen burning begins, causing a dramatic rise in temperature to about 2 million degrees Celsius. The different colors in the image represent infrared wavelengths, which are mostly invisible to us. The only visible parts of the image appear blue. The hues also increase with the red radiation in the image, since the protostars generate radiation at a wavelength 6 times longer than that of the human eye. According to Bill Nye, this image not only demonstrates the infrared capabilities of the Webb telescope, but also the formation of stars like our Sun. The first exoplanets were found in the 1990s, and today there are more than 3,000 confirmed planets orbiting distant stars. However, only a dozen of them have been directly imaged. Most exoplanets are so far away that they can only be detected when the light from their host star is dimmed. The first direct image of an exoplanet was taken in September last year. This planet was identified in 2017 and given the name HIP 65426b. Scientists used coronagraphs on the telescopes to exclude light from the central star, along with 2 of the Webb telescope's cameras, a series of filters, and other equipment to observe it. The planet has several features that make it easier to see. In addition to having outstanding infrared sensitivity, this planet is extremely far from its host stars, a distance 100 times greater than the distance between Earth and the Sun. It is a massive gas giant, nearly 12 times the size of Jupiter. Although the ghost galaxy is difficult to see in the sky, its brightness can be captured, especially when photographed with an infrared camera. The spiral of the galaxy and its array of stars extending from a radiating center are visible in the optical view of the object, also known as M74. However, a recent image from the Webb telescope shows structures that look like fibers of heat emitting dust and gas emanating from a bright center, depicted in electric blue. This new image will illuminate the star-forming regions scattered along the galaxy's spiral arms in infrared light. Photos from the Hubble and Webb space telescopes have been combined to create a stunning composite image that highlights portions of the optical and infrared views of the galaxy. The composite image was produced by researchers at the European Space Agency (ESA) as part of the FANGS project, an international project that uses Hubble, Webb, and a number of ground-based telescopes to observe 19 nearby galaxies in the infrared. With Webb's sharp observations at longer wavelengths, astronomers will be able to identify star-forming regions in galaxies and accurately measure the masses and ages of star clusters, as well as the characteristics of tiny dust particles wandering through interstellar space. In an image of a distant star known as Wolf-Rayet 140, taken in July last year, a recognizable diffraction pattern, a visible imaging artifact, was observed. However, this star is also surrounded by an equally unrealistic pattern of wavy concentric rings with a slightly square shape. These rings, in contrast to the diffraction pattern, are characteristic of massive stars known as Wolf-Rayet stars, which are in the late stages of their lives and have already emitted a significant amount of hydrogen. The interaction between WR140 and its small companion star is what gives rise to the peculiar shapes of the rings. The Webb telescope was designed to see the farthest galaxies in the universe. In mid-December of last year, researchers announced that they had detected 4 of the oldest known galaxies, seen for the first time by Webb. These galaxies date back 13.4 billion years, when the universe was only 350 million years old, or about 2% of its present age. These 4 galaxies were thought to be extremely old, similar to the hundreds of other galaxies discovered by Webb. The researchers determined the age of the galaxies as part of the JADES extragalactic survey, using information from the near-infrared spectrograph to rapidly measure the galaxy's remoteness. This elongation of light waves, caused by the expansion of the universe, is measured by the redshift of galaxies. The largest redshift ever measured was 13.2. To them, these galaxies are more than we could have predicted to discover before James Webb. For the first time, we can locate remote galaxies with this telescope and then spectroscopically verify that they really are that far away. Meanwhile, the Webb telescope has studied a planet orbiting a star in the constellation Virgo, conducting one of the most extensive investigations of extrasolar planets. The planet's name is WASP-39b, and it is located 700 light-years from home, about 8 times closer to its star than Mercury is to the Sun. This Saturn-sized gas giant boils as it orbits its star. The planet's atmosphere is dominated by thick clouds containing sulfur and silicates, including sulfur dioxide. Scientists were able to identify carbon dioxide in its atmosphere using 2 of Webb's spectrographs.